Okay, multiplying radicals. So, like usual, I don't like these investigations. So I'll just write a little bit of notes for you. There's like no space there, so. Okay, so back in 10C, you learned some exponent rules. And the exponent rules were on that sheet of paper I gave out yesterday with the two charts, remember? So one of the exponent rules is power of a product. And that's what we're doing today. Do you guys remember the exponent rule for the power of a product? What happens with the power? Does it go on to both? So you have something like this. Okay. So on the right here, you have a product of two separate things. Okay, so let's analyze what would it look like if you had radicals. Okay, and let's just use square roots. Do you recall, ignore that, do you recall this rule here? X to the 1/2 is square root x. Do you guys recall that? This is a Math 10 exponent rule. Anybody remember? Hands up. What's the story? How do you know that this is a square root? What's the little index right there that should be there? And where is it coming from on the left side? The denominator, right? So what would x to the 1/3 be? Cube root, right? What you mean? Right here. So let's take a look at something like, what if we had this? X to the 1/2 times y to the 1/2. What would we do with that one? No. This right here looks a lot like this, right? So it should be equal to this, right? So we'd write x times y all to the power 1/2, right? So all it's saying is that if you had a root x and a root y, what can we do? Smush them together. I think you guys already knew that, didn't you? All right. So multiplying radicals, let's say we had something like this. A root b times c root d. What the heck would you do with that? This thing here. Smush b and d and times a and c, because a and c are just like numbers, right? They're just coefficients. So you just times a and c, and then if it's in the radical, you times those. Is that hard? No. So that's pretty sweet. It's pretty easy. And all we're going to do is extend that into distribution. So we'll use this idea with distribution. Do you remember distribution? This is the simple distribution. What happens with A? It goes inside, right? And then the other distribution, which you had to do a little bit on the chapter 1 exam, FOIL. People call that FOIL, right? Where you distribute onto both, like this. So that's all we're going to do today with radicals. Sound fair? All right. We shall begin. And I really like that they start with this one. So please put a big star on that. And this is a fact that you can memorize. If you multiply these squares like this, and they're identical radicands, the answer will just be the same thing that's underneath. Okay? But let's just do it if we were to show it longhand. You smush it together, so you get 8 times 8, which is of course 64. And then the square root of 64 is 8. So it's the same number that you started with in the radicand. So you can generalize that. So in general, you have this idea here. Root x times root x is just going to be x. Please memorize that one. Whoops. Please memorize this fact. In general, root x times root x is x. All right. Let's do the next one. The 4 and the 3 go together, it makes 12. The 5 and 6 go together and make 30 inside the radical house. Is 30 factorable with squares? Does 4 divide it? Does 9 divide it? Does 16? No. So we're done. That's done. You can't do anything with that. Oh, exact same thing on the outside. So 12. And then what's x times y? Well, xy. Challenging stuff so far. Now we have the outside has a negative times a positive. And then on the inside, 8 times 12 is 96, I think. Okay, 96. Anything divides 96. Probably 4. The better one, 16. Zahara, thank you so much for being diligent. 32 is not a square, though. 32 is not a cube either. Oh my gosh. I'm failing today. It's a 32 is a fifth root. Very good, Jacqueline. So hey, what was this, Zahara? 16 times 6. Thank you. The 16 comes out as a 4, and then like what I would do with some of you guys, like, yeah, this is okay. So I'll just write it out. Ignore what I was going to say. Sometimes I get ideas and they're stupid ones. So any questions on this so far? So it feels pretty similar to the last unit. So you just have to multiply and then simplify. Multiply and then simplify. Multiply and then simplify. Next page. Okay, so now you can start to see the first examples of distribution, okay? So when you distribute, often I would recommend just putting in some arrows and doing them one at a time. So this first one is going to be 2 root 5 root 10. And I'm just being really diligent with my steps. You guys, if you feel strong enough, you can skip this step. Root 5 times root 5. So all that step is the distribution step. So some of you probably like, that's so easy, I'll skip that. Some of you want to see it, so I put it up there for you. Just the distribution step. And now you can smush. I got root 50, and then I got root 25. But you guys already memorized that root x times root x is x, so this is just 5 over here. Now the root 50 is an easy one. What's inside 50? Good. And what I do, like sometimes when you get good at this stuff, I was like, okay, 25 and 2, right? So the 25 is going to come out as a 5. 2 times 5 makes 10, and the 2 stays. So you can do a little shorthand, a little brain activity without, having to write the next step. And I apologize for this off-centered final answer. I don't know why that happened. Any questions so far? Looks like you guys are doing okay. Okay, so what's happening with this one? The 2 root 5 has to do what? Distribute onto all of them or just one of them? All of them? Okay. So let's just do the first one. Do you want me to write the distribution step or just get into it? Write into it or write it? Okay, 2 root 5 times 3 root 45. How about another color? Will that even help some more? Two root 5 times 3 root 5. It's almost easier to just do it because I'm going to have issues with my signs. Okay, so that's the first one. Plus, now let's do the next one. 2 root 5 times negative 8 root 5. Plus the last one. 2 root 5 times 3 root 20. So that's distribution, and of course you'll always just sum it all up. What's going to happen with the middle term sign? The sign in the middle will turn negative because it's a positive times a negative. You guys see that? Okay, so first one, 6, and then we have a root 5. And I'm just going to be a little bit clever here, because if I go 5 times 45, you're just going to get an even larger number that you have to think about. So why not just leave the root 5 and start breaking down the root 45? So I dealt with the 2 and 3 to get 6. I've got the root 5. Now I just need to figure out this root 45. Yeah, root 45 is like root 9, root 5. I like split it. See how I split the 45? 9 times 5 is 45. Now look at this. This is interesting. What's root 9? And what's root 5 times root 5? Root 25, which is just 5. 6 times 5 times 3, 30 times 3, 90. There's the first term. Holy smokes. The other option is to just go 5 times 45 and then try to break that guy down. What is 5 times 45? Probably like 225. And 225 is actually a perfect one. So that one would have actually been pretty nice. So you could go 2 ways on that one. Okay, now for the blue ink. So 2 and negative 8 make negative 16. And then root 5 times 5, root 5 and root 5 make 5. Remember, root x is x. Root 5 is 5. And 16, 5, what's that going to make? 80. So we're going to have this negative 80 here. And remember, we're just going to total all this up. That's all we're doing, totaling it all up. Now we're into green mode. 2 and 3 making 6. And now again, 5 times 20 is 100, and square root of 100 is 10. So that's actually really easy. The other way you could go is, what's 20? 4 and 5. So 5 will be left. 4 comes out as a 2, and 2 times 5 is 10. So I'll do this one different than I did the first one. So on this first one, I broke down the 45. That's an option. And on this one, I'll brute force it, and I'll get root 100. And it worked out nicely. So 6 times 10 and 60. Add all that stuff up. 90 minus 80 plus 60 is just 70. So all that crap just turned out to be 70. Weird, right? Weird. Okay. Now this one looks like an intermediate step on a FOIL. So all we have to do is distribute a 2. That's not going to do anything. So 2 root 3 minus 2 root 5. That was very easy. Just because I'm just attaching. Like, what's in front of these radicals but a 1, right? So you're just timesing by 1. You're going to get the same thing, right? Now, this second stage, you're multiplying in a negative. And we can't put negatives inside square roots. So you have to leave that negative on the outside, and you get root 12, 2 times 6. This last one, again, you're going to have to leave that negative on the outside, and you're going to get root 20. So 12 and 20, very doable. The stuff in the black ink you can't do anything with, so just rewrite it down to the next step. Now that you've had a lesson and a quiz, I saw like all you guys I bet got 100, you know, I almost guaranteed. So we're going to do these a bit quicker. And this is what I would do if I was just like by myself in a math class trying to do stuff. So I'd be 4 by 3, this would be 4 by 5. The 4 would come out as a 2. The 3 stays. This 4 comes out as a 2 and the 5 stays. That's how I would do it. Now we got some like terms. I'll color them for you. Got some root 3's. Got some root 5's. What's happening to the pink? Cancels, very nice. Just 2 minus 2 is 0. 0 times anything is going to be 0. So those guys are vanquished. And in purple, a negative 2 and a negative 2 will combine for a negative 4. Done deal on that boy. Fascinating stuff, hey? Kyle's just absolutely riveted. I know, it's not always too exciting, but we got to learn our algebra. Okay, let's distribute. So we have a negative 4, a root A, a root A. That's all it is. Distribute onto the second term. And negative 4, negative 9, positive 36. And then you have a root A and a root B. What's root A times root A? So you got negative 4A there. And then because A and B are different, you just smush them. And you have root AB. Any questions on this lovely radical business? Okay, well let's just keep going then. In this book that you have, this workbook, they will often put shapes up for this radical stuff and then make you do some basic geometry or whatever. So area of a rectangle, obviously, length times width, and area of a square is just going to be side times side, or side squared. Okay, so just jot that in so you know. Area of a rectangle, obviously, length times width. So 7 minus root 6 is the length, and 4 plus root 6 is the width. Now right beside this, in a different color, I'm going to put the word FOIL. And when do we FOIL? Binomial times binomial. And when you do this, you're going to have 4-term expansion. Okay, there's a 4-term expansion. A lot of people will forget about the middle. It's too sad to see sometimes. But this was taught in Math 10C. Every teacher in the school's taught it. I know it for a fact. So you must know this stuff if you're going to stay in -1. You got to know how to do these quadratic expansions. So come with me. We got 7 times 4 being 28. And then 7 goes and scales this one as well. You got 7 root 6. So that's the first distribution. And 2 terms came out. Now we're going to hop into the second number and do another distribution and get another 2 terms. So in there, there's a composite 4 and a negative 1, so negative 4. And then we have this radical 6. And now the last term, you have a negative 1 times positive 1 for coefficients, so negative 1. You don't have to write the 1. And then root 6 times root 6, 6. And that's going to happen so much in the next couple days that hopefully you just memorize it. Root x times root x is x. Now we can collect some like terms. We got a 28 and a -6. They're both whole numbers, so we got 22. And then we got a couple using root 6. So 7 minus 4 is +3 root 6. So there's the area of this supposed rectangle. Any questions? Oh, you guys seem to be doing just fine. The next one is also the exact same question, just with a square. For some reason though, students will make more mistakes on the square than the rectangle. Okay, so area of a square is just going to be side squared, right? 5 times 5 is 25 if the side length was 5. This time the side length is some random radical. So that random side is 2 root 18 minus root 27, and it all has to get squared. And this also is done using a binomial expansion. Because when you square something, you have to repeat it twice. You repeat the base, which is this 2 root 18 business. You repeat it twice. And then you FOIL. A lot of students will mistakenly just square the first two and forget actually about the middle term. And these work out so nicely because of the root times root that are the same. Okay, so you can see that you're going to have identical radicals. Like root 18 is going to times root 18, and it's going to be 18. It's going to work out quite nicely. All right, let's take a look. First distribution. 2 times 2 being 4, and then root 18 is 18. And I'll use color to help you stay organized. Now the second distribution, the coefficients are 2 and -1. Those multiply for -2, and then root 18 and root 27. I'm just going to write them like this because I don't know what that is. 18 times 27 is too big. So I'm just going to leave it. I'm just going to leave it. Now, in the blue, we have -1 outside and +2. So you get -2. And you get that same business, right? Root 18 and root 27. And the very last one, in purple here, that one's so easy. Positive or negative? Positive because negative times negative, so we got +27. All right. So the outside, or pardon me, the first, the outer, the inner, and the last. The first and the last terms are whole numbers. So let's just figure those out. 18 times 2 is 36, times that by 2 is 72. And 72 and 27 is Wayne Gretzky, 99. Okay, so that's dealt with. Just did some quick mental math on some whole numbers. Now let's deal with these radicals. Look at my whiteboard. -2x equals what? Negative how much? -4x, right? So that's what you do with the middle here. -2 and that garbage, -2 and that garbage, that's the same garbage, becomes -4 this garbage. Any questions on that? It's identical to this whiteboard. The root 18 and the root 27, just think of it as an object like x, or apple. -2 apple minus 2 apple is -4 apple. Any questions on that? Okay, good. Now, let's deal with 18 and 27, because that's a way easier thing to do than whatever 18 times 27 is. I don't want to deal with some massive number that I have no clue what factors it. I want to work with these small numbers. 18 is going to be like 9 times 2. How will that 9 come out? Okay, so 9 comes out as a 3, and you still have a root 2, yeah? How does 27 work? 9 times 3. 9 will come out as a 3, and you're just going to be left with root 3. I'll draw in some arrows to help you. And now we can combine. What do we got there? 4 times 3 is 12. 12 times 3 is 36. We got a negative 36 and a root. Help your teacher. Good, Jordan. Combine that with the 99. And you get your final answer. 99 minus 36 root 6. That's your final answer. Okay, so expect some complex multiplication problems on your exam, okay? Expect it. It's going to just look just like this. So practice makes perfect, as always. Nothing really too conceptual here. It's more just sort of skill-based. So can you do the skills? And then conjugates. Is that the last stuff? Yeah. Right, sweet. Okay, conjugates are used in calculus for these things called limits. So if you plan on taking a calculus course, these conjugates actually are quite nice. It's like another algebraic skill in the tool belt. Anybody recognize the word conjugate? Yeah, so it's from the difference of squares. So how does the difference of squares factor? You take the roots, right? And then one's plus and one's minus. So these two pairs are called conjugate pairs because they're identical binomials. One's plus and the other's minus. We call this a conjugate. And they multiply so nicely because it's just the square minus the square. And this is a very sweet pattern. And I would memorize this for this test because you could do this so quickly. So quickly. This is just going to be 5 minus 2. This is 3. Whoa. Slow down, Mr. Lineweber. What did you just do? Root 5 times root 5 is 5, yeah. And root 2 times root 2 with positive and a negative is going to be negative 2, yeah. But where'd the middle term go? Yeah, so when you do this difference of squares, let's do this difference of squares on the whiteboard. Do it with me. You get a times a is a squared. A times negative b, negative ab. And then positive b, positive a is positive ab, same thing. And then minus b squared. And you notice the middle term is vanquished. Bye-bye. Okay, so I will show you that longhand on this second one. All right, go like this. You get 4 times 7. Do you agree? Because the root 7 is just 7. And 2 by 2 is 4. Now for the outer, you got negative 16 root 7. And I'm going to leave the inner in green as well. And we get a positive 16 root 7. And then I'll put the last one in black. Positive times negative is negative 64. So I'm just getting 28 minus 64. And what happened in the middle? They kind of cancel out, or they for sure cancel out? 99.9.9 forever? Sounds good. This cancels. I agree. 28 minus 64, I cannot subtract like that. So what is that? Please help. Say what? Can't end in a 7, I don't think. Negative 36. Thank you. You might have just typed in the wrong button. I do that sometimes too. I got fat fingers. See that Homer Simpson when he's like really fat and he's dialing the... Yeah. Anyways, so, do you guys want to do that one more time with this one? So what's the shortcut? Just use the difference of squares, right? Use this. This is a minus b, right? This is a plus b. So we know that this will always equal the difference of two squares. So I just need to square this. I get 5. And I need to square this. And I get 2. And I just subtract them. 5 minus 2 is 3. So that is optional for you to memorize. If you don't memorize that, could you still brute force it? Absolutely, right? So if you just follow the method, you should still arrive at the same answer. If you want to be quick and clever, you can go with this way. If you want to brute force it like this, there's no shame in that at all. Go ahead and do that as well. So here we have some conjugate binomial, and just add in this word here, conjugate binomial radicals. So they want us to write the conjugate and then multiply each pair. So for conjugate, just put this next to it, just copy and change sign. That's all you gotta do. Just copy it and change the sign in the middle. So you got 4 root 6 plus 3. The conjugate, I'll put it in red. What will it look like? Copy it, but instead of plus, put minus. Good. Now we can brute force this, or we can be clever. So if we just be clever, it's going to be, and if you go like this, a plus b, a minus b, it should just equal a squared minus b squared. If you recall your math 10 factoring, difference of squares. Here, let me just jot that in for you. Maybe you want to write it down in case you forget. Difference of squares. All right. So all we have to do is square the first term and subtract the square of the last term. So how can we square 4 root 6, and how can we square 3? Well, 3 is easy. It's just going to be minus 9. Now the first one, a little bit more challenging. You got to go 4 times 4, and root 6 times root 6. 6. And 16 times 6 is like 8 times 12, which is 96. Ooh, I got lucky. 96 minus 9 is, oh, I can't subtract. 85? Is it? Oh my gosh. I can't subtract, promise. All right. Next one. Do you want to brute force it, or do you want to do the clever way? Brute force. Brute force? Oh, one person said it, so we'll do it. Oh, we have 3 here. Oh my gosh. Okay. I'll jot down the original in black ink. And now in red ink, put the conjugate. Oh my gosh. So we copy. We copy, and then what do we change? Sign in the middle. And I'll put a arrow to that change. That one's plus, that one's minus. That's how you do the conjugate. Pretty lame, eh? I need to get a life. Are we brute forcing this one? Oh yeah. I'm going to go underneath this time. So negative 3 is a positive 9. Come on, Mr. Layton. And root 11 is 11. Good. And then all the way over here, minus 3 root 22. You guys okay with that? Or did I screw up? Don't be afraid to tell me I suck. What did I screw up? Negative 3, negative 1 should be, and I'm pretty good at math, right? And I just screwed up. So what does that tell you? That I suck? Or that you guys should just be very extra careful and double check your work? Yeah. No, I usually screw up and I see it and then I want to look good, so I just like turn it. Try to make it look like a learning experience. No, like every day I try to tell kids that it's okay to fail. It is, because how else are you going to succeed later if you don't fail? Like I remember the first time my kid strapped on skates, the guy would get up and fall. Get up and fall. What's he doing? He's failing. But what happened on the very next day? He could stand up. But it took him a while to fall, right? You a little bit of failure and then you succeed. A little bit of failure and then you succeed. And then next thing you know, you're a master. And people start calling you master. Okay, all these arrows are confusing me. I feel like I have like dyslexia here. Let's change color because I'm just losing my mind here. Okay, let's go in this way. And we got negative 3 because there's a positive 1 on this one. And then root 22. Oh my gosh. Root 22. And then the last one, a negative and a positive. So this will be negative, and then root 2 and root 2 will just be 2. What do you see in the middle? Some cancellations, right? Positive object minus object, the same stuff, that's gone. And then again, we got Wayne Gretzky, minus 2, Connor McDavid. Connor McDavid! Was there a faster way to do that? Let's use green to do faster. Square that. What do you get? 9 times 11. Square that. 2, and then subtract. Oh, it's the same thing. So if you're clever, you can skip a lot of work, right? All right. Let's do this last one cleverly, and then you're off to the races on your homework. Square this bad boy. You get 25x. Square this guy right here, you get y. Subtract, and you're done. Wow. Homework. Oh, who said that? Okay. So the more you do, the better you'll be. So 1, and if you want to do every second one, I'm not going to cry about it. And 3 and 4. Okay, and then basically this page is so crucial. Like, spend some time on this page. Really work on this page. If you can master this page, you're going to have some success. And you know what? Like, if you run out of questions, like you do all these and you screw up a few times, you check your answers, like rewrite them on a separate page and do it again. There's no harm in doing the same question multiple times. There's no harm in that. And then definitely do 9. And if you just want to do A and B, that's fine. Okay, and for 10, 10 is going to be just like 9b. Remember 9b, you have to do the squares and FOIL out a square. So for 10, they all look pretty decent, except for C has a 2 on the outside. I'll just give you a hint. Just deal with the FOIL first, and then multiply the 2 in last. So do this first, and then multiply in the 2 at the end. Okay, do this, you know, multiply in at the end. So that's 10. So if you wanted to do like B, 9b and 10b, that would be okay. And if you did 9a and 10a, that would be okay. So much stuff. So with 11, try brute force, but also try clever. You know what I mean by clever, right? So that would be for all of these 11 to 13. And again, for 13, you don't have to do them all, but more practice is better. And let's do 15 together right now. Let's do 15 together right now. One less thing for you to do. How many times do I write out root 2? Okay, do that. You guys are so kind to each other. Okay, some of you already got the answer. That's clever. So if you just do 2 at a time, what do you get? Root 2 times root 2 is 2. Root 2 times root 2 is 2. And this one you can't do anything with. These combined for easy one, right? Sweet. One less thing for you guys to do. It's actually the walk the plank. Yeah, the root 2 plank walk. That's what we'll call it. Well, they would travel around on their little boats. Yeah, the cultist Greeks. Okay, so 16 and 17 are, of course, sometimes you get these really bizarre, like, numerical response style questions, and numerical response occur on diplomas. So students who are really interested in making sure that they're prepared for diploma exams in a couple years, try these. Okay, it doesn't have to be tonight, it doesn't have to be tomorrow, but please try these numerical responses when you have some time. Okay? So if you can live in page 115 and 114 and 113 for tonight, I would be so pleased. You want more?